Hello, 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 welcome, welcome. Hello, 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 ooh, hello, welcome. People coming in. Hello. Okay. Hello, 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 um, hello. Okay, for can you guys? So my name is Yaverbaum. We haven't met yet, any of us. Can you see me?
Yes.
Great, thank you. And thank you for that bold, gutsy yes. Okay, great. And that also answers the question. I get you can, and you, I gather, can hear me, and I can hear you guys. It seems, or you can hear me, right?
Yes.
Yes. Okay. Okay. Great. 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 It's good to see you. And I know not everybody's here. Okay. I'm stalling a little bit because there's every possible reason why tons of people would not be here yet, because of course you only even found out where to come a couple hours ago, thanks to me. And I totally missed class last week, 100%. And that would lead to all sorts of justified confusions. And I'm very sorry about that. To anybody who's, I'm going to say this a couple of times because I know people will still come in. I very much apologize for missing class last week. It was exactly as dumb and ridiculous as maybe you think or no, which is I absolutely did not think the semester had started yet. And that is entirely my fault. I don't know what that tells you about me, but it is the case that I just blew that completely. But I know the semester has started now, and I do love this class. I mean, I don't know you guys yet, but I have been teaching Physics 102 for a while with Walters. We love teaching it together. I love working with him. We love this particular class. Like we always we always choose to teach this class and to teach it together because it's usually, well, at least we think, fun. I have been teaching physics at this level. Maybe you know this stuff, I don't know. But just to tell you quickly, I want to get to know you guys, but just I am because we've already gotten off to a rocky start of me not being there last week. So I can't make that up to you. I certainly will make up the material. Like just if anybody's concerned, any material that we would have done last week will be made up and not on your dollar. Like I'm not going to assign you an extra 3 hours someday because I missed that class, but the material will be made up, I assure you. And certainly any consequence, anything that you'd be worried about in terms of grades or this or that, obviously, everybody still has the A that they had walking into the room, as far as I'm concerned. And only I've done anything to jeopardize my own A. But so you know, I've been teaching physics, this type of physics at this level since 1992, which is about 28 years or so, which actually means I've been doing this for a living longer than many of us have been alive. I mean, in the room, which is weird. But I'm doing it. I love it, and I love it every year. And every year, in a way, I get worse at it, and every year, in a way, it gets harder in some ways because there's always a new challenge. Blah blah blah. But I'll tell you this: I've been teaching physics for a long time, but I've only been teaching physics in a virus on Zoom since about March of last year, like exactly the same amount of time that you guys have been trying to learn on Zoom. I think it sucks, to be blunt. I mean, I think this virus, I think this is only making it harder on everybody, education-wise, that we're in this situation. I am already making mistakes as a result of it. You have my advanced sympathy of how hard it is to do school this way, like especially science. Like I definitely know that going in, that this is not easy on any of you. And I know, for example, why, if I were in your position, I probably wouldn't put my video up like most of you don't. I mean, I want to talk a little bit, we're going to talk a lot in this class. We are going to have discussions and all this kind of stuff. It's a very long class, as you know. I really do believe from experience that the class time goes a lot faster than you would ever believe. Like I always dread it. I always dread having to walk in and do a 2.5 hour thing, believe me, especially if it's me talking for 2.5 hours or something. But it actually will go a lot faster than it seems. I think we'll all find, maybe not today. And it is understood that none of you can sit at a desk like in this way and sit and deal with me for 2.5 hours straight. Let me tell you in advance, I get that people have to come and go in the middle of these Zoom sessions for any reason that might involve like your own life that you're trying to juggle at home, or might just involve how incredibly boring and mind-numbing it can be just to sit in front of a computer while someone else is talking for hours. So I get that you can and will come and go as you please, like hopefully not rudely, and do what you need to do. And you don't need to put effort into hiding that fact from me. I think it is already weird for everybody that like you're all sitting here. Like, I think you know this, you're all sitting here in Zoom with name tags on you, right? Which is bizarre. Like even if you want to be completely inconspicuous and just listen, or if you want to be inconspicuous for super solid academic reasons, like you need to concentrate and take notes, which there will be a lot of notes, believe me, once we get rolling, or you want to be inconspicuous so that you can juggle other things. Either way, you're all at a disadvantage right from the start that you're sitting here with a name tag in front of me. So if you do nothing the entire time, I have a nothingness to associate with that name tag. That's a bummer. What I want to say to everybody is, if you put up a picture or something of any visual, even just the color orange, or like a cartoon icon or something, you don't have to put what you look like. You don't have to put what you're doing right now in live video time. But can I encourage all of you to put up something as an image for you, just so that I start thinking of you as a human being more than just like weird space in my weird head on this weird computer. Like, you know, if we were in real college right now in the building, I would be encouraging people to, you know, visit office hours and visit each other, all that stuff. We can't do that. We're already at that disadvantage. But like, okay, let me put this more bluntly. Everybody comes into my physics class and into Walters's physics class with an A. Did someone just do it? Oh no, pardon me for a second. You enter our class with an A. It is possible to lose that A, of course, by doing enough things wrong, or by neglecting to do enough things, like by not taking exams, Oh, sorry, hold on, I'm looking at the Zoom. I'm looking at the chat. Ooh, whoa. Oh, no, this is good. I totally love, so I'm looking at the chat right now, and thank you, Samantha. Let me say right now, what Samantha just did, I totally appreciate. She totally put a chat thing in that's relevant to what I'm saying. She put it in, so if I didn't want to be interrupted, it wouldn't be an interruption, right? But it totally shows me that she's paying attention to what I'm saying, and it actually gives me information that I didn't have a second ago. Like, I actually didn't know that you need to be able to log in to do that. So I'm glad she's telling me. And I'm really glad that she had the guts to put it in the everyone chat so we can all see. The more anybody and everybody can do that at all times, please know, I'm a talker. I will keep talking to fill a silence. I will keep talking until someone interrupts me or something, and I'll keep talking at a disadvantage. The best way to ever say anything in this class is to interrupt me, and I totally welcome interruptions. If I totally can't handle it at that moment, you know, I'll say, hang on a second, whatever. But I really am glad that Samantha just raised that. Is that true? Is that the deal with like a lot of you, that you actually couldn't put in a profile picture even if you wanted to? Is that what people, or is there a hint that someone could give? Oh, thank you. Totally appreciate that. See that? I mean, if someone has it like another way and can tell Samantha, that would be helpful too. But let me say too, I'm just saying this at the beginning because I want you guys to know, you start with an A. You could lose an A by doing enough bad work or not enough work or something, but A, we don't have an objection to everybody getting an A. I want you to know, I went through college too. I went through graduate school twice too. I know what curves are like, and I know what grade distributions are like, and I know that there can be this concept that only a certain number of people can get an A and a certain number of people have to get an F or something like that, and that you'll have to be cutthroat to get, like, there can be that concept. That is not the concept in this class. The concept is if you all get an A, that's fine. Maybe I have to teach harder next semester if you do, you know, maybe I'll take it out on the next people, but there's no reason that everybody can't get an A. I mean, there are reasons, but you have to do those reasons to not get an A. And here's the thing that I'm getting at is, if when the end of the term comes and you're like on the borderline or something, if you've done like a lot of work that puts you numerically right on the cusp of B+ and A-, like all I have to do is know that you're a human being and have some compassionate for you. And that will be enough to push you over the borderline if it comes to that. But if I literally know nothing, if I have nothing to go on, like just literally a name in a black box, then then that's the easiest way for me not to give somebody the benefit of humanity and compassion. So anything any of you can do to like bust through the Zoom problems and just sort of get me to know you as different from other people is good. We'll figure it out. Great. And you could take your time, and all this is just a suggestion. There's no rule about this. If you don't put up a picture, I'm not actively going to punish anybody, of course. But thank you for the people who are already doing it. I will also say, here's another reason I understand why people don't put videos up, is because what if the professor's recording and posting the lectures? Fair point. I am, and before I forget, so you are being recorded. We are recording. It's for so that I can post everything to you, so that once we get into really heavy stuff, once we get into really mathematical problem solving and like a lot of information, which we will, then it's advantageous to be able to replay the lectures and slow them down or catch parts that you missed. Blah blah blah. So all of this will be recorded and is posted. And let me give you the address right now. I'm going to. If we didn't put this in the Zoom classroom. So this link I'm going to send around right now is the YouTube link to where, basically where all my stuff is. That includes other classes. So you're welcome to look at anything. This class will be a new, the class for this semester. There's no recordings yet, obviously, because we're just starting now, but there will be a playlist at this YouTube channel called P102 F20. And just each class, after we have it, at some point in that night, I'll upload everything we did in the class to YouTube so you can watch. And I mean everything. I don't have the time to edit or anything like that. So whatever I put up is like everything. So then, just delete what you are, fast forward around, whatever. But it's there, it will be there. And therefore I understand why for some people that's a reason alone not to put their own faces in. I mean, I wish that weren't true, but I totally understand that. So here's the link. And someone's at divorce. You could try it right now, I believe this. This link that I'm giving may be to a playlist on that channel. You might have to like pop out of the playlist and go to the channel itself, but hang on. There's another, but I think this works also. You can test if it, yeah, so and everything I'm talking about right now is in reference to my part of the class. Like, to back up, I missed last week. That was my bad. I apologize. This is where this part of the class will be. Like, this Zoom address is where we'll be every week from here on in, on Wednesdays. And every Wednesday, and it will be the 2.5 hours. Again, maybe we'll go a little bit early today if we can. But usually, believe me, we will fill the 2.5 hours with discussion and stuff and problem sets and breakout rooms and not just me talking. But at the end of everything, the recording will be posted to that YouTube channel like at night. And I also might put other recordings in there in between and assign for work, like before an exam and stuff. But that's all just to say, again, anytime you have something to ask, if you're paying attention and something occurs to you that you want to ask either about the actual physics material once we're doing it or the class itself, I really do encourage people to stop me or put in the chat. I would discourage private chats just because like you could put in a private chat, I need to talk to you after class. Can you hang out for 5 minutes? Yaverbaum. That would be a totally reasonable thing to put in the private chat. By and large, if you put something in the private chat, it takes me twice as long to read it and then figure out a way to respond to you without slowing everybody else down. So, but if you put it in the public chat, I promise you, I will honor it and like probably stop on a dime for whatever you're asking, just because it's easier for me to interact with human beings than with myself. That said, I'm gonna stop for a second. I think, so you still can hear and see me, right? You're all still there?
Yeah.
Yeah, great, thanks. Oh, and that said, you don't have to mute as far. Oh, I'm sorry, what? Go, I'm sorry.
Before in the waiting room for the Zoom call, it like posted this Google Classroom link that you had to join your class, and when I tried to use it, it wouldn't work.
Oh my God, wait. I'm so glad you just said that. Okay, that's really helpful. I'm sorry, are you Anastasia?
Yeah, Anastasia, yeah.
Anastasia, okay, sorry. Right, totally helpful. Okay, so that waiting room thing, thank you for, I knew I had a waiting room sign up from last semester and I did mean to use the waiting room, but I totally forgot that I did not check that. That is my bad. That Google Classroom link is defunct or is to a different class. I'm very glad you brought this. So I will change that, number one. The waiting room.
I was just making sure because I don't want to like add a classroom and then it wasn't working. So
no, you're totally right. No, I'm glad. And that brings me, and it's funny too, because where we're going with this next is, it is my belief, well, I'm pretty sure, Walters set up the Google Classroom with you guys last week. And I do want to make, there's no way you could know this without me saying, yes, Walters and I use, well, first of all, we both do use Google Classroom, but more to the point, we both will share, we're both teachers on that same Google Classroom module or whatever for this class. So in other words, everybody who signed into Google last week to the class with Walters, that's the very same roster that I'll be using. Like we do everything together. So that's the good news. If you signed up there, then you are already signed up for the correct Google Classroom. And in about a minute, we are all literally going to do an assignment exchange in a moment so that everybody can get 50 points for today. And I do mean that. I'll explain that more in a second. But everybody's going to do an assignment in a second. That's going to be super easy. And as long as you actually do it, you'll get 50 points for it, which will count as homework points. And so yes, this assignment that we're about to do is on the Google Classroom thing that you already signed up with Walters. Is there anybody in the room right now, though, anybody who can hear me right now, who was not here? Is there anybody here who does not know about the Google Classroom thing that I'm referring to? Okay. Is there anybody here who did not sign up with a Google Classroom or did not join a Google Classroom class for this class? So far, it's looking like no, it looks like everybody did. Okay, great. So if everybody did, what we're gonna do now, I'm gonna literally give you an assignment right now called Trial 1. It's like just a test to make sure that we're both on the same page of how to do homework and turn it in to me, because it might be just slightly different with Walters. So in a minute, you're going to get an assignment. I'm going to tell you what it is right now. It's going to ask you to write your name on a piece of paper and then write your preferred email address on a separate piece of paper. Again, it will say this, but I'm telling everybody right now, the whole assignment for right now is literally just going to be on one piece of paper, write your name, and on another piece of paper, write the email address that you actually use for this class that you already used for Google Classroom. And then I'm going to ask you to take those 2 pages of real honest paper and use whatever method you want to scan them into your computer or take pictures of them with your phone or whatever method you want to get those 2 sheets of paper into your electronic system so that you can then compile it into one PDF file. I know this is so boring, by the way. I know how boring this is, but I just want to have this clear before we ever go on. I want you to take those 2 pieces of paper, those 2 sheets, those 2 pages, and compile them into one PDF. And I do mean PDF. Are there any exceptions to what I mean? Yes, there's one exception. It could be a Google Doc. If that is also fine, but that's the only exception, like not a Word doc, not an Excel spreadsheet, not a JPEG, not a picture file. As rigid as this sounds, but this is why we're doing it now, I'm going to ask you to turn 2 separate pieces of paper into one, preferably PDF file, and then that's going to be the one file that you're going to submit to the assignment portal that you're going to get in a moment. That's going to open up, like you will get an assignment from me. You're going to put one PDF consisting of 2 pages in there for me right now, and then you will get 50 points from me. And we should both witness all of this happening like here and now in the next 20 minutes. In other words, we're not done until you get your 50 points. But I literally want us all to both to be able to like experience this together in real time so that from here on in, if I ever need anything from any of you, whether it's homework or an exam, which will probably be take home, and we'll talk about that, then like this is the way you're gonna do it. And this is the way you're gonna expect to get your points and all that. Oh, wait, sorry. So let me look at the chat. Oh, wait, okay. Yeah. So what I'm saying, and I'm glad, and this is why we're doing this now for these kind of questions. Like there's no assignment yet, but in a minute you're going to see an assignment. And the larger point I'm trying to make is, right, for any assignment I ever ask of you, wait. So what I'm saying is you're going to have homework from me, okay? Maybe it'll be every week. Maybe some weeks we'll skip it, like, who knows? And maybe sometimes homework that you'll get from me will literally be in the middle of class and you'll do it together and then turn it in. But I mean, you'll get assignments from me, right? Whenever you get them, what I'm trying to say is that for a given assignment, I'm going to want it as one PDF file that you're going to submit to Google Classroom. Like we use Google Classroom to assign you work and to collect work from you. And we use Google Classroom to send you the grades as well. So I'm not saying how much homework you're going to get or that you're going to do this every week. I'm just saying that whenever you get work from me, there's a procedure that we do to do that. And we're going to all do that procedure right now in a moment, or we're going to do it in a moment, but it can't start until, like, in other words, I'm going to send you an assignment in a moment so you can see how this goes. I haven't sent it yet, so there's nothing anybody can do yet as such. But in a moment, I'm going to send you an assignment that basically says, put your name on one piece of paper and your email on another. It's not meant to be a hard assignment. And in a moment, you're going to get that and then send it to me, and then you're going to get 50 points back from me. And once that happens, then we'll all know that we know how to exchange work. Like, and if anything gets snagged in the future, we'll know who's missing what. Am I making any, like, there's nothing you can do yet, but am I sort of making sense now? like Ekaterina or Ariel, do you get what I, oh.
Yeah, just want to make sure, like you say, it is assignment PDF gonna be through Google email, right? I've sent it to you through email or Google Classroom.
Yeah, all right. This is all going to be through Google Classroom. So wait, I think one of the reasons I'm confusing people, hang on, let me say to everybody, if there's any confusion, it's partly because nothing has happened yet. Everything I'm describing is about to happen. Like if everybody just hangs tight for a second, you're going to get in a moment a notification or an assignment. You're going to get something in your email address that you use for Google Classroom. So hopefully it'll make it clear in one moment. So I think, yeah, but the biggest thing I could say is what we're all about to do, we're going to do as slowly as we need to make sure we get it. There's no rush on what we're about to do, but we are all about to do it right now. And when we're done, everybody's going to have 50 points. Okay. No one's going to fail at this, but we're all going to do it. So you'll see what I mean as we're doing it. But Ekaterina, do you want to ask something before or are you raising it? Hello? No?
Yeah, it was me. I just asking for you a couple of questions about it was Google through Google email or through Google assignment. Like we have to choose.
You'll see. You'll see the email that this is going to come to your email, and you'll see in 1 minute. I see what you're asking. Okay, hang on 1 second.
Okay.
Okay.
Thank you.
No, thank you. No, thank you.
Can you also just like refresh the page on Classroom? Is it like going to be public?
It's going to come to your email. You can refresh. Bear with me for 1 second because I think it'll be much clearer than it sounds like in 1 second. Okay, so far still nothing has happened. Nothing has happened. Something will happen in 1 moment. You're going to see what I'm talking about. Bear with me. Okay, now I believe right now, each one of you just received something in your email that you use for Google Classroom. Like you'll see an assignment that just came in, I believe. And it's called P102 trial homework number 1. I believe this all went to your boxes, to 13 boxes just now. And I believe that if you open it, if you see it, it's giving instructions that just say to write things down on 2 pieces of paper. The ultimate purpose of the assignment, all you're going to give me is you're going to give me 1 PDF consisting of both of those pages. 1 page will say your name, the other page will say your email. It's just to make sure that I need to see that everybody understands how to put multi-pages into one file. So, but once you have that, you're just going to actually submit that file into the assignment. Like you're going to press attach or whatever, and you'll know you've done it correctly because once you've done it and I get it, you'll get 50 points. Right now, in other words, does everybody understand what I'm at? It looks like I'm starting to get them. All right, it looks like people know what I'm saying. Right, and again, I'm asking that so that is, and again though, I want please 1 PDF, or it could be Google Docs, but not a Word document. You'll see why I can't grade those in the same way. They don't work in the system, but at least 1 person just put it in and I got it, and they're about to get 50. You'll know that you're done and we're good as soon as you get a 50 from me. So far I have 1 person and I think she just got a 50, and I'm not trying to be weird, but I want everybody to get a 50 before we're done. So do people see what I'm asking? Oh, okay, got another one. Cool. All right. I appreciate it. And all I'm doing is I'm opening up and checking for each person. Okay, did they give me 2 pages? Does one page say their name and one page say, and the other page say, right. And as long as I see 2 pages, then I'm like, great. And I give you 50 and it counts. It's not a joke. This will count in your homework points. And obviously homework gets harder, but I just want to make sure, but this is always how we do it. And again, so, and if you just did it and you just got your 50, cool. Like you can chill for a second or go get a drink or whatever. So I think now 2 people have gotten back, I hope. I think. So again, and we're going to move on. I know this is weird, but we kind of all have to relearn how to do school now that we're all in a Zoom environment. So we're just all making sure that we know how to get a perfect grade in this class. And again, you're starting with a perfect grade until things go imperfect. All right, I just got another one. Thank you. And I'm just, each one, I'm just looking to make sure it's, and this is also the way I grade. Like once we start having hard homeworks, like the first thing I look at is just did someone even put it in a way that I can, because if I get the homeworks this way, I can grade it and turn it all back fast and stuff. But other ways will slow down the whole system. So, sorry. This is literally the way you're going to turn in exams. Believe it or not, you're actually going to turn in your exams this way. So this is why I'm just making sure. And the lesson here is the people that have gotten the 50 right now. The lesson here is if you have a document that's 50 pages, like your exam might be super, super long. Your exam could really be like 20 or more pages, but you're going to put all those pages together and give me one file for them. Also, what I'm trying to say with this, all right, so I got more, cool, thank you. And again, if you got a 50, you can go take a break for 5 minutes. I don't want to waste your, how many? But if you don't know what I'm talking about, or you don't want to just be sitting right now, I mean, you do want, in a minute, I'll also put you, if you want, I can walk away so people don't have to ask anything in front of me. But if you don't get that I'm asking you to, let me put it another way. Another reason for this system that we do it this way is I want everybody to know whatever work they do for physics, whether it's for Walters or for me, whether it's like a homework assignment or an exam or a lab stuff, whatever you do in physics, people have their different ways. You don't have to type out when you're thinking in physics. It's hard for a lot of people to think while typing. You can always write out on a separate piece of paper to figure out anything, but then you still have to get it to me electronically. Like, I mean, of course, now in the Zoom world, I just can't get anything unless I get electronically. This is the electronic method that will allow us to stim. Okay, I just got another one, thank you. And again, and you know, this is like also, of course, I am not looking to see who's paying attention and who's not, like I said before. But of course, with little things like this, it becomes increasingly obvious if one person's just sitting there for a half hour and everybody's ready to go and we're just waiting on that one person, you know, that would be embarrassing and you don't want that to happen. So we wouldn't be looking for it, but it can happen accidentally. So this is just another like, let's stay together kind of thing. But okay, I just got 2 more. I think I just gave 2 more 50s. Also, can I ask you guys a question? Once you've put in your email address to this Google, you cannot change it. Is that correct? Does anybody have an answer to that question?
Yeah, I think because with Google Classroom, you have to create a Gmail account in order to even use Google Classroom.
Oh, okay. Oh, well, I don't think it has to be a Gmail, but okay. I see what you're saying. Okay, I hear you. Thank you. Oh, but here's a question in the chat that I just saw too, from Vicky. Right. So, and this is a good question. And let me say to everybody, maybe I answered it already or not, but it's a good question. And today's the day. Like, it doesn't matter if, I mean, we want to make sure we know the answer. So yeah, I'm saying today I want it handwritten. What I'm really trying to tell everybody is I want you to know that you do your homework however you do it. And most people would prefer to handwrite their homework and figure things out. So you do your homework however, but then you scan it in or you photograph it in to get to me. And so handwritten is the answer. I want it handwritten, but then you're gonna scan that into your phone and send it to me. And this is where, again, like for a lot of people, the way they'll scan something into their phone, the way a lot of people turn a paper document into an electronic document is they take a picture, and that's totally fine. Everybody can do that. and if you have a 5-page document, you can take a picture of each page, but one way or another, I cannot accept 5 JPEGs as an assignment. Like one way or another, all those pictures have to be put together into one thing that I view as your assignment for 1,000 reasons. But I promise you, and this happened on an exam once, everybody hands in one exam, one file that might be 20 pages long. One student one semester handed in like 25 JPEGs, one of each different page. There's no way I can go through that or find what's what. And if I could, then I'd have to give a separate grade on each one of them. But it was one exam, and it bogs everybody down. So I'm just here to make sure I'm asking you to have it handwritten, you know, or whatever way you would generally do work, whatever your preference is. But then please get it to me as one PDF. Okay, I'm going to look back on who's gone so far. And I know this is boring, and hopefully class will be more interesting than this, but hopefully this is boring because it's easy, not because it's hard. And then hopefully we can get to interesting things because of having done this. Also, again, since I missed last week, that could cause confusion. So I just want to make sure we don't have confusion. I think 3 more just got, I think. Okay, so now I believe that may be everybody. Let's see. And I appreciate it. Thank you all for bearing with me on that. Let's. Oh no, a few more. So can so there's still some more people, please do this or talk. What I'm gonna do, I'm gonna put you in breakout rooms for a second. Okay. Okay, no, and this is fine. And thank you for the honesty in the chat. Again, this is all weird, right? Like doing school this way is weird. So we just have to all figure out ways to make it work. And I appreciate like someone saying, sorry, it's taking a while. I did airdrop. Yeah, that's totally fine. Good to know. I don't mean to rush anybody. And it's also good for whoever's trying this right now to know that if they ever had to rush a homework assignment, like they've got to budget this time in or whatever. I don't mind waiting. I'm not trying to rush anybody. It's good to know if you get what I'm asking and you're working on it right now. I mean, and of course, if everybody just wrote me right now, like, yeah, we get it, but can we do it later, Yaverbaum? I mean, I will accept these for the whole week. I mean, everybody who but this is now a homework. Like your homework number 1 is write down your name. And so it's such an easy 50. It is going to count in the sense that if anybody ever doesn't do this, they just blew an opportunity to 50 that will, not help them. So if so please do this if you can't do it right now, or let me know what the issue is, because I guess the simpler way to put it is if we can't do this, we're not gonna be able to do anything else. But so did anybody have any, do you see what I'm asking? Does anybody else have any questions of how to do this right now? Actually, yes, I'm gonna do one last thing so that we can move on. And I don't want to embarrass anybody, but I need to know that you know how to give me homework if you have it. So I'm going to put everybody in breakout rooms for a very short period of time. I think you've done breakout rooms and I think you know what I'm talking about. For about 7 minutes, I'm going to put you guys in breakout rooms. They're random. They have nothing to do with whether you've given me this homework or not. But the purpose, yeah, don't worry. No, it's fine. If it's taking a while, it's totally cool. I'm not trying to but of course, I just need to know what's going on. So I'm going to put you in breakout rooms so that some of you might have some tricks to tell others of how to do this faster or whatever. The reason I'm going to put you in breakout rooms is so that you'll know that I can't hear what you're talking about. And I'm a very big believer in that. Like with the breakout rooms, if you've never done them before, or whether you have or have not, like I can come into a room, but when I do, it says my name and it shows clearly that I've come in. If it doesn't say my name, there's no way I can hear what you're talking about. And therefore, I think for a lot of people, it's much easier for them to be honest and help each other because they're worried about what happens in front of the professor. So in a minute, I'm going to put you all in breakout rooms. Any of you who have not turned this in yet, please turn to the others for help or vice versa. If you have all turned it in your room, then just take a break for 2 minutes and bear with me. I apologize, but I'm going to put you in rooms for like 2 minutes just to help each other. And again, I'll know that we're done once I've got all of these from at least all of you who are here right now. So we're going to do this. Okay, so you should, and also this is so that we can test what it means to go into breakout rooms. I do like the breakout room thing. So please go as soon as, yeah, thank you, awesome. If you're still hearing me, you're gonna get an assignment to a breakout room, just hit join, awesome. If you're still hearing me, hit join, great. Thank you. Thank you. Great, great, great. Oh, Andreas, can you hear me? Andreas? Oh, thank you. Great, great, great. Okay. Oh, hello, did you go to a breakout room, Alexandra?
Yeah, the people in my group knew how to upload it.
Okay, all right, so they're good. All right, thanks for your patience. Okay, now we're going to start again in a second, but someone else. Who is that? That is. Hello, hello. Okay. Thank you all for your patience. I think we're almost there. Although I do have to ask, Vicky. Are there two Vickies in the room? I guess is my question. Is there one Vicky in the room?
Yes, I think there is another one.
I think you're right because I hate to call him, but you are, wait a minute. You are, oh, wait a second. You are Vickyology, not Vicky Tello, correct?
Yes, I'm trying to change the name now.
Okay, thank you. I appreciate. I wasn't gonna. All right, but okay, thank you. That ends that discussion. All right. But you, so okay. And again, I'm saying this. I hope this doesn't embarrass anybody. But if it can, the other Vicky, can you hear us at all? Because I do believe there's another Vicky. Is Vicky Tello here? No. Okay. Tiffany Persaud here? Or Tiffany? Any Tiffany? Or Elia Abidi? Elia? Okay. So this is sort of how, look, I think it's weird that we take attendance at this college, and I think it's weirder, even weirder in Zoom. I'm not a big attendance taker as such, but this is how, but I am like a let's all do the work and everything kind of guy. So, I mean, the reason I just asked, so those 3 people are not here right now. That explains why they haven't turned this in. It does look like, and I hope they do come at some point. I hope they turn it in, but everybody else, it does look like got it in. So thank you very much. Oh, but one thing, there is one person, and again, not to embarrass anybody, but the point is that I need one file containing both pages. If you got a 40 on this, okay, got it, Anastasia. Yeah, did I call you? Well, let's see. Wait, Anastasia. No, yeah, you're good, Anastasia. But there is at least one person I gave a 40 to, which is not a punishment or anything, but it's certainly, there's 10 more points you could get if you just take the 2 pages and compile them into one file. I really need to see that though. I can't have one file for each page because again, things can get long and it won't let, well, right, but here's the thing, right, it won't. Okay. Right, this is what I guess I should make clear to everybody. One of the reasons we have to take this step is I completely agree that Google Classroom will not let you, it will not take multiple pages and assemble them into a file itself. It won't, but there is a way that one can do that before one even gets to Google Classroom. There's various ways. I would say some ways are better than others, but to everybody, or if I could just say this quickly, the easiest way to do what I'm saying, as long as you have a computer, is take a separate picture of each page, but then open up a Word doc, insert one picture onto each new page of a blank Word doc, like start a new Word doc, put the first picture on the first page, then scroll down to the second page, put the second picture on the second page, do that for as many as you need, but then save the whole thing, but then print as PDF. Like some people don't know about that option. And if you do, again, I'm sorry to bore you, but with Word, and you could do this with Google Docs too, I think you can always print as a PDF, which technically means save it as a PDF. So once you do that, then insert the PDF into Google Classroom. So, but I'm actually not trying to rush anybody. As long as everybody knows kind of what I'm saying, even if you got a 40 today, if you just submit this later on and just let me know you did, it'll change into a 50. And by the way, last thing, that's true of any homework. The other reason we're doing this, if I assign anything at any point to any or all of you, there will be a due date for it. Like in Google Classroom will tell you the due date and all that. And once, if you're past the due date, it'll tell you you're late. But I will accept things late. I will accept things late. And I'll also always accept new copies of things. If I assign something and you guys turn it in, but then we go over stuff in class and then you have a better understanding of it and you want to correct your understanding on the homework, even based on what we did in class, even though I just told you corrections, you can and should totally do that. I welcome that. I will know that that's what you've done, but that's the point. Like you can hand in improved or revised versions of homeworks as much as you have the time or interest in doing. I consider everything a draft. We're always getting better at everything. But I do mean that. I mean, if enough time goes by that it would be ridiculous to, like, if weeks go by, maybe I don't want to accept homework number 1 anymore, but then I will just take the portal down. Like as long as the link is there, as long as you electronically can get something to me, then you can assume that I will give it credit. And maybe if it's super late, maybe I'll give it like less credit than otherwise, but I will give credit to anything, and new versions I'll give credit to. But that's all the more reason why everything you give, you want it to be one file. Otherwise it's super confusing to me, like, you know, whether two things are 2 different drafts or 2 pages of the same draft or what. Okay. But so now hopefully just everybody starts off the class with a 50 or will be assumed to be corrected. That's the first thing. The second thing is, let's start finding out. Oh, and I haven't decided. So I will, when you're done tonight, late tonight, if we actually get anything done today, you'll see a video posted of what we did today on YouTube, but also at some point tonight, you'll probably get a homework that's due next Wednesday. Like I might not post it till tonight or tomorrow, but it won't take you a week to do, I promise. It won't be a big deal. And you'll turn that homework in before next Wednesday through this method. Like you'll find out about it through Google Classroom, you'll turn it in through Google Classroom. And if it turns out you don't finish it, you know, and they have to turn in more later, that'll be fine too. But what you'll do on any homework that I assign is you'll answer every question. You'll show work, you'll make clear what the question is, and you'll answer the question with like a box around the answer. And you will get full credit even if you get wrong answers. Like it will, just to be clear, Walter's probably already said this, but except on exams, what matters is not right answers, it's right process and thoroughness and clarity and all that. So you can get full credit on every homework, even if you get wrong answers, but you, all right, I'm just letting more people in the waiting room, sorry. All right, well, having said all of that, in a minute, we're gonna start an activity together and I'm gonna stop talking, but I do need to hear, I believe from your point of view, you did a lab, I mean, from all points of view, you did a lab yesterday, obviously a Zoom lab, that's weird, blah, blah, blah. But can anybody take a shot at trying to summarize, like, can anybody tell me what either you did or what you think the upshot of it was, like either what you were supposed to learn or what you were trying to learn or what you don't understand? I mean, obviously I do know, I talk to Walters all the time, but like if anybody can give me a brief synopsis of what they think the experience was, I would love to hear. Like, what'd you do in lab? Oh, sorry, go, I'm sorry.
So we did the measurement of 5 masses by spring, and each mass has each volume have a different mass, and we figure out net force, spring, and what else, and acceleration in the lab. And also we figure out if motion been happen or not. So motion being found out by Hooke law formula. It is.
Oh, so you got, okay, I think okay, thank you. I think I understand. And sorry, the person who was just, I'm sorry, can you tell me your name again? Who just answered that?
My name is Katerina.
Oh, you're Katerina. Right, okay. So that was helpful. Let me, right, you tested out different things on springs. Hold on, we're gonna go to the next page. And you, Katerina and everybody else, you can see this blackboard, right? Like where I'm about to, like you can see this board, right?
Yes, yes.
Okay. Now, and is this, tell me this is over. I want to make sure if I heard the last part correctly. Do I hear correctly that you're saying you looked at masses on springs and did some tests or investigations and stuff to ultimately to come to a conclusion that they obey Hooke's law? Is that what you said, Hooke's law? Did I have that right, or did I just make that up?
You can stay on mute.
Sorry, what? Yes. Oh, okay, yes, okay, thank you. So all right, so Hooke's law, if anything was a finding of yesterday, and we'll talk about what you mean, if anything was like the upshot of yesterday, it sounds like people are telling me it's Hooke's law. Now, can someone tell me what is Hooke's law? Can anybody phrase, like, what is Hooke's? I mean, I don't know if it's English or a math equation or what, but there's some. Or anyone, Bueller?
It is equilibrium. I'm sorry, I cannot spell it. Equilibrium of spring. So it is distance multiplied by equilibrium of spring. It's like x multiplied by minus k.
Okay, got it. Thank you. No, that's helpful. And I see in the, okay, that was helpful English, which I need both. I got that English from you. Thank you. And I see in the chat that people are saying something that looks like this. And we definitely need, but I agree with both. I just want to make sure we're all on the same page. Like, this is what I'm seeing, and what I'm seeing in the chat is an equation that I do agree with. I'm not trying to trick anybody. That is the equation that I would think best expresses Hooke's law, or yeah, you could say it like that. And I do agree that the English for it is essentially what Ekaterina was saying. To make sure that we're on the same page, yes, yes. Yeah, the F definitely stands for force. I completely agree. Just to make sure, and force is something from physics 1. It's about like something that's measured in, if we're talking about units, force is something that's measured in newtons, right? Okay, I definitely agree. And the X, could someone tell me what's the X stand for, or what's it measured in, if that helps? Like if this is a law that says about what the force exerted by a spring is, according to this law, the force is
displacement.
Cool. Yes, I totally agree. I totally agree. And that's measured in what kind of units?
Meters, I think, right?
I totally agree. Yes. Awesome. 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 Thank you. So, and again, look, I know this is not fascinating yet to anybody. I know you just did this. We're trying to go, but I'm not trying to trick anybody. We got to go slow and simple at the beginning just to know where we're at. Everything starts from slow and simple, but believe me, this will build, if any. But yes, by X, we mean displacement. We do mean displacement. And we do mean that is displacement measured from equilibrium, which we call X equals 0. It's definitely, yes, by X equals 0 is what we mean. Like, I'm going to notice I'm saying X triple equals sign 0. We'll get more into this, but if Walters didn't already say, there's 2 types of equal signs that are really different and really both super important in all of science and all of math. But for some reason, a lot of people it doesn't come up a lot until physics. But in physics, we make a big distinction between 2 different types of equal signs. One is a double equal sign, one's triple. When I use a triple equal sign, what I mean is, I mean equal by definition. It's a much stronger kind of equality in many ways than a double equal sign. Like, anything that's equal by a double equal sign can be proven wrong, or there can be exceptions, or it can change. But something that's true by a triple equal sign means it's true by definition, and therefore cannot be changed by discovery or experiment, because it didn't come about that way in the first place. So what I'm getting at right now is, okay, we're going to imagine that we have some mass m on some spring that I just very badly drew. Some mass on some spring, and the spring is like attached to some wall on one end, like it's a rigidly fixed spring on one end. On the other end is this mass that's free to go back and forth. I mean, like your lab, in other words. And what everybody's telling me so far, and I do agree, I just want to make sure that we're on the same page, that wherever that mass would sit naturally by itself, if you left the spring, if you put the mass on the end of that spring and just walked away and just let it sit there, wherever that place would be, we're calling equilibrium, and we're defining it as 0 meters of displacement, right? Wherever the mass would sit forever if left to do so. Any other spot that we put the mass, anywhere where if we put it and then walked away, it would start moving, is something other than 0, something other than equilibrium, some displacement from that. And what you guys are telling me, that I do agree, again, I'm just making sure that we're all the same. What you're telling me is that the takeaway of the lab from yesterday was that the farther, I'm going to write this on the next page. This is what you're telling me, I believe. And again, I'm not trying to trick you. Like, I believe this is right, what you're telling me, but I just want to make sure we all. What you're all telling me is if we have some spring that's rigidly attached on one side and has a mass on the other side, that wherever the mass would normally sit, like where the one and only one spot where if you put the mass there, it will stay there. Okay, that equilibrium spot, if we call that 0, if we define it to be 0, then if we place the mass anywhere else besides that, if we place the mass and hold it somewhere far away, some distance, some specific distance, call it x naught, you guys are saying the spring will exert a force on that mass to pull it toward equilibrium. Like if I hold the mass to the right of equilibrium, the spring will exert a force pulling the mass to the left. And what you're telling me in this law, F equals negative kx, what you're telling me, well, I guess I'll ask you, according to this law, if this law is true, and I believe you, I agree with you, like that. Oh, I'm sorry, question? 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 No, okay, if this law is right, and I think it is, but I want to make sure I understand what it means, then according to you guys, are you saying that the force exerted by a spring on a mass, the force that the spring exerts in order to get the mass to equilibrium, are we saying that that's what you would call a constant force or a variable force? Like, is this force going to be one constant number as masses are moved back and forth, or is the force itself going to change in magnitude? What are we saying?
I think it's a constant.
Okay. And you are Andreas?
Yes, because the force, if you change the force, let's say as yesterday that we increased the force by like few points, then displacement changed. So if you divide the force by the displacement, you get the same constant that you have earlier.
Wait, very good. Okay, wait, that was a lot. That was, so, I think that was great. And when I say something's great, it doesn't always mean I think it's the end of the, or in fact, it never means I think it's the end of the discussion or that I agree and that there's no possible disagreement. I do think what he just said was great, but wait, did anybody else, before I say anything specific about it, did someone else just want to say something about what Andreas just said? But like my question was, is the force constant? And then he just gave a very good explanation of something. He did say something very like that if you double, if you double the displacement, then the force would double by the same amount. He definitely just explained something that I think is very right and very important. But well, I guess I'll just ask again, given your explanation that you just gave, Andreas, would you call the force constant or you would not call the force constant?
Oh, in that case, it's not a constant, because if it changes, it's not constant.
Okay, right, but yet what you're saying is still true. Like what he's saying to me, I want to make this clear to everybody, and it's clear that he gets it, even if we're using different words. I do think he gets it, but the fact that he gets it shows, or the words are tricky. What he is saying to everybody is the force exerted by a spring is not constant, right? It isn't. I agree with him. Like the force exerted by a spring can get stronger or weaker depending on where you're holding the spring. It does get stronger or weaker. That's in fact, let me write this down. Hold on, we're going to write this down. What I'm saying is unlike the force of gravity exerted at Earth's surface, okay, let me make this super, super clear, because like there's two sides of a coin here, and both of them were expressed by Andreas, honestly. But they are two sides of a coin, and they can be hard to hold in the mind at the same time, sometimes for some people. What I'm saying is Oh, well, first let me say, when I use the word elastic, it's the same word as the word spring. Like whatever you call the force exerted by a spring or the spring force, we can also call the elastic force or the force of elasticity. It's all the same. A spring is anything that is springy, which means anything that elastic material is made of lots and lots of little springs, and one big spring is just one concentration of elastic material. So it's all the same. And what I'm gathering from what Andreas is saying, and what I'm gathering from this equation is, if you hold something above the ground, near the surface of the earth, we all know that the earth will exert this force called gravity on that thing. So I'm holding a pen right now of mass M. I'm holding it 10 meters above the ground, okay? Let's say this pen has a mass, let's say this pen has a mass of 2 kilograms. I'm holding a 2 kilogram object above the ground. Now it has a weight, it has a force, there's a force of gravity exerted on this thing from the center of the earth. The earth is pulling it down. With how much? Well, with approximately 20 newtons of force, right? I mean, if it's a 2 kilogram object, you could say 19.6 newtons of force are pulling this mass down toward the surface of the earth, right? The force of gravity is mg. If I pull the object up to a higher height, just to be absolutely clear now, if I pull an object up to a higher height, if I hold it at 20 meters above the surface of the earth rather than 10, the force exerted by the earth is still mg, at least as far as we ever said in physics 1. Like the force of an object, the weight of an object is mg, whether you hold it this high from equilibrium or you hold it this high from equilibrium. What's equilibrium in the context of gravity? Equilibrium is the ground, right? So no matter how, as long as things are reasonably near to the ground, no matter whether they're higher or lower, the force exerted by the earth is the same. It is constant. What Andreas is saying on the one hand, and again, I'm not trying to trip him up. Like I agree with this, but I want to clarify it. What Andreas is saying is, if you change where something is on a spring, if there's an equilibrium position of a spring, like it doesn't have to be, it could be vertical or it could be horizontal. Once it's a spring, we're talking about a spring now. If this is the equilibrium, if where this hand is the equilibrium position, and I pull out the spring a little bit over to here, the amount of newtons exerted by the spring is one number. But if I pull the spring and if I hold the mass at a different position, the spring is exerting a different number. We're literally saying that according to a Hooke's law, the force of elasticity is not as simple as the force of gravity. The force of gravity is a constant force near the center of the earth, near the surface of the earth, but the force of elasticity is not constant, because it changes based on position. It's the first reason we study it, because but on the other hand, so now I'm going to write this. On the other hand, when I first asked the question, is the spring force constant or not? Andreas gave a really good explanation, and it was perfectly right. But interestingly, at the beginning, it almost sounded like he was saying that the answer is yeah. Like he explained something that almost sounded like it was explaining the constancy of the force, whereas I just got through saying the force is not. What I'm saying is this. What I'm saying is this.
You don't want to sit over there, but I'm going to be working in here. You want to sit in the living room? Save it. I'll walk around. And just get out there. I always put it there.
Okay, just to be absolutely clear, what I'm saying so far is the first thing we have to know about springs, and the reason we study them, is they exert forces which are not constant. They exert forces that get stronger and stronger the farther and farther away the end of the spring is from equilibrium. The force of a spring is not constant, and that makes for some interesting consequences. On the other hand, there is something constant about it, and this was the second thing that Andreas was saying. The thing that's constant about the force of a spring is the ratio, or the rate at which it grows larger and larger as you make the displacement larger and larger. In other words, the first graph here on the picture, and please do write everything down. This is take notes, please. I guess that's obvious, but again, everything in physics builds from small steps. And so and the steps will get larger and larger as we go. But anyway, this first graph, the force itself is constant. It's always one number of newtons. In the second graph, the force, and it's a graph of the same things. I'm sorry, position. It's again newtons versus meters. But here, the graph is changing. It's increasing. It's just that the rate at which it's increasing the whole time, that's what's remaining constant. So to speak, the slope, if you like, the delta y over delta x, or in this case, the delta f over delta x, right? The rate at which the force rises in relation to any run in the displacement, that is what is a constant. And that constant is what we call K, okay? And that constant, the number K is a constant. It's not a force, but it's the rate at which the force grows depending on growth in position. And as long as everybody's, so I'm saying K is like the slope of the force displacement graph of a spring. But just to make sure we're on the same page, could someone, maybe someone other than Andreas, because I think it's clear, I think he does get this, could someone tell me what units must K be measured in if everything we're saying here is true? If force is measured in newtons and displacement is measured in meters, what units are K measured in? Like I'll even put, if this statement is true, which is what everybody's telling me it is, if we believe that statement, then the units of K must be what?
I think Newton on mass, Newton divided by mass.
Close. Newton, yeah, definitely newtons divided by, yes, newtons divided by what?
Meters.
Yes, right. And I understand why someone would say mass because of the M, but yes, absolutely. And I know you both meant to say yes. Hold on. Right. For what we're saying is for one given spring, the K is constant, right? So for any one given spring, it can stretch a lot or it can stretch a little. Therefore, it can exert a lot of force or it can exert a little bit of force. It can exert zero force if it's just sitting there in equilibrium. But the number of newtons that it exerts for every meter of stretch, that is what we call K. K is how many newtons of force the spring exerts for every 1 meter of stretch that you ask it to undergo, okay? That K is measured in newtons per meter. That will be constant for one given spring. And what it's really measuring in a way is the strength of the spring, or what you might call the stiffness. K is a measurement of the stiffness or strength of the spring. Each spring will have one strength or stiffness, which is the slope on that graph. When we say it's constant, we mean for that spring. We don't mean from one spring to the next. Like different springs can have different Ks. And a K will be something roughly like generally like 150 newtons per meter or 250 newtons per meter. But those are but the higher the numbers, the higher the strength. Okay, this is what we're saying about springs so far. This is the essence. So anything that we ever call springy in physics means it's made of materials. Like if we call something springy or elastic, it means that it's made of lots and lots and lots of little springs, each one of which is behaving like this. And maybe that means a little coil of metal, or maybe it means something on the atomic or molecular level. Like a spring doesn't always have to literally be a coil of metal. It is a system that behaves according to this. Is everybody with me so far? Good. Just pause for a second. So this is what I think we're saying that you got from lab last time. 1 second, I'm sorry. 1 second, I'm sorry, hold on. We want to start doing things with this mathematically, but everybody with me so far? Well, okay, it's 4:15. This close. Okay. I'm going to pause for 1 second. if there's no questions on this, believe me, I would like, if possible, I would like to let people go early today. I'm not going to fill time just to fill time. There's things we still need to get to, and we do. But believe me, I won't fill your time just to fill your time. I would like to let people go early if I can, but there's still something we have to do. So we're going to say right now is you can take, if there's no questions right now, take like a 5-minute break to get a drink, go to the bathroom, whatever. I'm going to do the same thing. Frankly, I have to do that. So I'm going to take a 2-minute break. You could turn off your screens or not, or whatever, but we're going to resume in like 5 minutes. And we're going to do an activity. It won't just be me talking, but bear with me for like 5 minutes. Okay, I am back. Okay. I told everybody to take a break, so you can still, we're still on break. We're still on break. But I will start again in a second. I appreciate your patience. How about this? Let's just say this. So please, so I'm back. Again, we're just trying to get to know each other. So please, when you see this, please raise your electronic hand once you're like, to acknowledge that you're ready to go and that you're here. So I'm basically, thank you. Or do the thumb up thing, right. The thumb up thing or the hand up. Please once you're ready, once you hit great, thank you. Awesome, I love it. Such a strange world we're living. Awesome, thank you. I see it. Awesome, I see it. Okay, that's most people. Okay, so again, once we're ready to go, you're just raising your hand or your thumb, and you can keep them up, well, either way. Okay, it looks like most people. Okay, good. So again, I'm gonna try to let us go a little bit early today. I don't usually do that, but I certainly don't want to fill time just to fill time, but there actually are, but I did miss last week also, so I don't want to lose material here. We have a first assignment in this class, the first thing that we should be discussing. If I had assigned it last week, you would have done it for today and we'd come here and discuss it now. But I didn't. The first question I want to ask everybody is, do you see that I just sent you? So I just sent everybody the assignment that's technically due a week from today. Can you acknowledge if you just got that, if you see that assignment that you just got?
I got it.
Okay, cool. Thank you. Awesome. Okay. Now, this assignment is what gets the physics actually rolling here. Like, it'll look more like regular. It looks like physics, I think. It is physics. It's technically due for everybody next Wednesday. Oh, I still haven't really told you how all the homework grades and stuff count in your grade. Unless Walter's already did, but the quick point is that every bit of homework that you do is points that go into a big pile of homework points, which then at the end of the semester get added on to your test average, your exam average, as just extra raw points. Now, like, in the manner of extra credit almost. Like, in other words, if a homework is worth 50 points and you get a 45 out of 50, perhaps because you literally left one question blank, let's say. So you did 9/10 of the thing, and maybe you didn't even do them all correctly, but you did 9/10 of it, so you got a 45 out of 50. Like, what does that mean? If you get a 45 out of 50, what it means is, first of all, is that 45 points go into the book, not a 90, not an A- or something like that. It's just 45 points go into the book. All your homework points are all added together. And at the end, say you have like 300 homework points accumulated at the end of the semester. Well, then we divide that number by something like, say, 30. And that will mean that if you did 300 points worth of homework, that you'll have 10 points literally added to your average at the end, that thereby raise your grade by that much. And that's for serious. Now, two questions. One, am I being realistic? Is that a realistic example? Actually, it is pretty realistic. Like, the amount of homework you do ranges from person to person, but homework can add on. Typically, it adds on like 8 to 12 points to someone's average. If they do it, it can add like 15, or it could add like 4 points if you don't do anything. It will never subtract points. But the amount of homework you do does add on in a big way to your average at the end. The other quick thing is, when I said you might accumulate 300 points worth, but we would divide that by 30 and give you 10, like, where did I get that 30 number from? Well, that number 30 is different every single semester. It's a number designed to basically allow your homework to help curve your grades, to be honest. So it's a different number every semester, but it's the same number for all students that semester. So basically, every number we come up with a number that would appropriately help everybody. We come up with a number that's the fair number to help everybody, but whatever that number is, it's the same for every single student. And it just means that your homework then gets scaled and added to your average. Anyway, I'm saying all that to say that you'll have a homework due this coming Wednesday. If you do all of it, you'll get all the points, and that'll be great. I think it'll start somewhat not so hard. It's like starts as a kind of review of Physics 1 stuff, but then transitions us into the more Physics 2 stuff. Oh, okay, wait, how long does it take for you to? Oh, yeah, that's a really good question. Okay, wait. So Ariel's question, let me get to that in a second. Very fair question, but a very hard question for me, because unfortunately I'm very bad about that. So, but fair. But let me say this. We're gonna, first of all, this homework that I'm talking about that's due next Wednesday, we're actually gonna start here today, all of us. We're gonna start it together here. So we're gonna make progress on it no matter what, and be able to generate questions here. Your job for next Wednesday, all of your jobs, is to try to write as much as you can and get to an answer for every one of the questions on the homework. I'm telling you right now that if you literally, in order to literally answer the very last question correctly and thoroughly, like, you almost would have had, you almost can't answer the last question without looking up a bunch of stuff on the internet or something like that, and then possibly writing things down that you don't necessarily understand. I'm saying that right now, that by the end of the last question of the homework, it becomes hard enough that it generates the topics that we have to do here in class. Like, we will, so that's to reinforce, you may get the last question wrong and still absolutely get full credit on the homework, which is why any questions you have between now and then, I try to answer, and I'll get to that more. But even if I'm slow in answering your question, or even if I don't answer a question in time, believe me, you will not be punished for that. You will get full credit for anything you try, and you can keep handing in even after it's due and stuff like that. Because, but to everybody, how do you reach me? I mean, that is a fair question. In fact, should I write this? How you reach me in general is through Google Classroom. That is to say, if you're doing homework, any comment you put in for your homework will go to me privately. It will go to the email address that I use for Google Classroom. And that is the first place I'll check for everything. If you put something in the stream of Google Classroom, like our discussion, that will go to me, and that goes to that email address. That's the first thing I'll check. So it is true, if you want to ask me questions or whatever, do it through this system. Do it through the email address I use for this, which I'll put in the chat right now, but it's this. It's not my actual John Jay address. Because my John Jay address, everybody uses, including faculty and all these things that I don't want to look at as quickly, but here, and I will try to make an office hour too, but here is, just to be clear, that's the email address that I use for the Google Classroom and all that. So send questions there. But we're going to start but assuming you got the homework that I just sent around, we are going to start it in a moment right here. And we're not going to get through it all, but we're going to get through a good chunk. And then whatever's left is what's due for next Wednesday. I want you guys, one of the reasons we're going to start it here, for homework, anything goes. Anything goes. What I mean by that, I mean, you can certainly go on the internet. You can certainly talk with one another. You can talk to people who aren't in this class. Our job is to learn anything and everything by whatever means necessary. There's no concept of cheating when it comes to homework. Well, there's a concept, but you do whatever you need to do to try to figure things out. But then whatever you write down for homework or for exams, write only what you actually understand. And that will be always clear and transparent. That is, you can figure things out with whatever help you want, but you get help in order to figure things out. Once it's figured out, you don't have to give credit or anything like that. But once it's figured out, you'll write it in a way that's clear and sensible because you've figured it out. And then that will be great. What nobody should do ever is like get information from other people that doesn't make any sense to them, but then just write it down anyway. I don't care about the plagiarism aspect of that. It's not my business. But the point is, if you just write things down that other people say, but you don't understand them, then it is clear when that's happening. And then that doesn't count for credit or for advancement, blah, blah, blah. So I'm just saying to everybody, whatever I call homework, you use whatever the more you can talk with each other, the better, the better. That's how I got through physics. I think that's how everybody needs to get through physics, is not alone. But just in the end, when you put your work down on a piece of paper, it's your work. All that said, is there a tutoring service? Oh, that's a really good question. Is there a tutoring service for this class? Well, that's a really good question. I mean, normally I have a very easy answer to that. Normally at John Jay, our answer is the MSRC, the Math Science Resource Center, is where the typical tutors come from. Now, I don't even know if that exists anymore during all the Zoom and the virus. I can certainly say that no matter what work I assign, to everybody, even if I assign work and even if I'm giving you a grade on something, certainly first and foremost, if you prefer the way Walters communicates or whatever, which is totally fair, you can of course go to Walters for anything that is not clear from me, and vice versa. You can come to me for anything that goes on there. We also have other physics professors that you can go to that I can give you their names and addresses if that helps. But as far as actual tutoring, that's a fair question, but I don't know what John Jay does about that during Zoom. I can explain how your tests are going to work, yes. Okay, these are fair questions. I feel like I'm not really doing a good job with that tutoring service question, but I may be able to answer it in more detail if I answer this next question of how can I explain how your tests are going to work? Yes, here's how the tests work. You have a midterm and you have a final exam in the class, and they technically happen in this part, like in the my part of the class. They don't happen generally during lab periods, and there is not a separate lab exam or anything like that. There's one midterm exam that covers both lecture material and lab material. In other words, I write part of it and Walters writes part of it. Then there's a final exam with the same deal. Okay, how the grades, your grade is, the grade that you get in this class comes essentially from, because lab is worth almost 40% of the whole class, what it comes down to is your entire grade that you get for all of your work in lab, it accounts essentially like one exam. Then your midterm is another exam. Then your final exam is a third. In effect, the grade that you get for this class, the easiest way to think about it is there's really three pieces that get averaged together, and then we add all the homework points to that. But the three pieces are all the stuff you do in lab, the midterm exam, and the final exam. So then that's how your grade works. But then how do the tests work, which I know is really what Tiffany's asking, is like the format and stuff. Here's how your exams work for real. And I may have to say this many times, but the way your exams work in this class, and we have not announced the dates yet. I mean, the final exam will be during the exam period, but we've not announced the date of your midterm yet. You don't know it yet. It will not be a surprise. believe me, but the way the midterm and the final exam work in this class is they are both take home, and they are like not 3-hour exams. For each one of them, you have something like, you'll have anywhere from 24 to 36 hours, something like that, to do the exam. Like, it's not, you don't do it under test conditions. You don't do it like in real time zoomed with me or something like that. It's a take home document that you have a full day and a half or whatever to work on, kind of like an essay test, if you want to think of it that way. And I know this is going to surprise people. This is a very, very, very fair question, a very important question, which we would have gotten to one way or the other. Your midterm exam and your final exam are both take home, and they're both open everything. That is a surprise, often enough so that you might not think you heard me clearly, or you might not think I know what I'm saying, but I do know what I'm saying. Your exams are both take home and they're open everything. Like, you literally could call up your friend who's in this class in the middle of the exam while it's still out there and due to me, and you could, and no, they're not timed. I mean, they're timed. Wait, let me, hold on a second. Kind of, right. That's good. The way Katerina, okay, as long as we're talking about this, obviously this is important. So let me be as clear as possible. It is essentially what Katerina just said. Let me just be super clear. But so the exams are, and if I have to write, well, this is in the syllabus too, but if I have to write it down, I will. The exams are timed in the sense that, like, the midterm will be posted on a certain day that you'll know way in advance. You'll know at least a week in advance, but we'll say, like, the midterm will be posted Wednesday, the blah, 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 at blah o'clock. And it'll be posted, and then you'll have like till midnight Thursday night to turn it in or something. So in that sense, it's totally timed. And let me say, there, you don't want to be late. Like, definitely be the case that whenever the exam is due, then you definitely have to turn it in for when it's due. And if the exam comes in after that, that's a problem. So in that sense, they're timed. But right. It really, they're timed just like an assignment that's due at a certain time where you should show all work. It's exactly what Ekaterina is saying. It's like a long, big assignment where you have to show, with a few questions, we have to show all the work. Yes, of course, it is longer and bigger than a typical assignment. Of course, we like to think it's also like harder and more comprehensive. Like, you know, the questions are real. You have to solve real problems. And yeah, you totally have to show your work because that's what you get graded on mostly. Like, we'll know the answers to our questions and know that you could look them up on Google. So it's totally about how much work you show and how much you show that you actually understand what you're doing. It totally is about that. But yes, absolutely, to make this super clear to everybody, what Ekaterina, as long as Ekaterina and everybody understands that that doesn't necessarily mean that it's a joke or that it's easy or something. Yes, it is like an assignment with a few questions where you should show your work. And I'll go a step further too. And again, this is where, I mean, I've been doing this for a long time, so I know how crazy this sounds, but I'll even go a step further. What we've always done in physics and will continue to do even like in Zoom is before you, oh, sorry, my internet connect. Can people still hear me? I'm sorry, I just got a thing that said my internet is unstable. Can you still hear me?
Yes.
Yes, okay, all right, because here's even the weirder part that I'm gonna say. And I know you don't know yet when your midterm exam is. It will not be a surprise. I'm gonna tell you soon, not this class, but probably next class. You'll have, not only will you have at least a week of notice before the exam happens, but what we give out to everybody is a practice exam, believe it or not. You will literally get a practice exam from Walters and me that will have the same format and the same expectations and the same look and everything as your actual exam. And that's part of the purpose of it. So you'll know exactly how the exam works and what the format is. You'll get that in advance. It will be very similar to your actual exam, like 80% identical and 20% not identical, of course. But you will even get solutions to that practice exam. You won't get them right away. Like, you won't get them at the same moment as you get the practice exam. You may have to wait for them a bit, and you may have to work with each other and try to figure things out and sweat it a bit. And I can even tell you now that the actual answers to the practice exam almost always come out a little bit later than anybody wants. Like, you'll start wishing they came out earlier, but they will come out to you. And in fact, wait, hold on. No, this is all good questions. I'm about to answer Tiffany's question. I love these questions, but I'll just finish this. You'll get a practice exam, and eventually you'll even get solutions to that practice exam. Possibly what might happen is I'll post a lecture where I go over the practice exam and walk through it and actually tell you not just the answers, but like the solution methods. And I'll even say, you know, if you want to know how to do this exam, watch this lecture. And of course that would be, you know, like I can't enforce that, but so I may give you the answers to the exam in the form of a lecture that you watch at night or whatever. But then by the time you actually have the actual exam, you will have no surprises as to what kind of format or what kind of questions that you were supposed to prepare for it. And then, right, to answer Tiffany's questions now, no, you'll upload your exam exactly the way we just practiced today, as boring as that was. Like, it won't be a Google form or something. It will be like, we'll ask a bunch of questions and then you on separate pieces of paper, like in other words, you'll use your own paper as a blue book, so to speak. And you'll fill out everything on your own pieces of paper and then put those all together as a PDF and upload it just like we just did. And honestly, that's really why we did that, because our exams are like that. And we don't want there to be any confusion by the time you get to the exam of how to get it to us. And we don't want anybody to be able to say, I didn't know how to get it to you, you know, and you don't want us to lose it and all that. So it will be just like what we just did. And if you think that everything I'm saying makes it sound like, oh, that's not very stressful like that. What if you're thinking like, what's the catch? Or does he know what an idiot he is? Like what a sucker he must be to have this arrangement for the test? Or if you're thinking anything like if you're thinking something like that's a joke or that's easy, then you are hearing me correctly. Then you are hearing me. Like, that means I am saying what you think I'm saying. Now, honestly, in my heart of hearts, I don't think it is as much of a joke as it may sound like. And as we get closer to the exam, I will tell you more and more why Walters and I do it this way, why I've done, like, whether it's in a Zoom environment or not, why we do it this way. You will find that the main purpose of why we do it this way is to get rid of inequitable cheating. That is to say, if it sounds like I've just told you that you're going to take an exam where everybody's allowed to cheat, you're kind of right. That's kind of what I'm saying, is that everybody's allowed to cheat. But the whole point is that then it's not cheating, right? What I'm saying is that you'll all be able to go on Wikipedia and Google and all that stuff, and you can call up like the ghost of Albert Einstein in order to do our exam, and you can talk to each other so that you can help each other. But everybody will know that everybody has all those advantages. So what one of you can't really do then is just like sneak the internet to yourself when everybody else is being a good person, you know, when everybody else is resisting temptation and working hard. What this means is that everybody will have all the same advantages, and we want you to work together and help each other so that you know more physics at the end. So as far as tutoring services are going, to bring this full circle, and I know I'm talking a lot, but this is very unusual, I know. And we've been doing it this way in physics even before. Like we give take-home exams like this in midterms for years. We do sometimes do it for final exams, believe it or not. And I've got stories for you that are crazy about what it means to cheat or not cheat in one of these things. But right, I'm not gonna be watching any of you. So when it comes to tutoring services, I'm a big believer in tutoring services, and I also believe that if you find a physics person who likes physics, generally they'll love to talk to you about it and help you whether or not you can pay them money, and that goes for my colleagues. But if you're talking about some things that call themselves tutoring services, but are something else like Chegg, okay, so can we all talk about this for a second? If you know what I mean when I say Chegg, C-H-E-G-G, oh, I have a lot of opinions about this Chegg thing. It is technically a tutoring service. And if you don't know what I'm talking about, look it up and then do whatever you want with the information. But Chegg is a service online by virtue of which you can pay and have an account, and they supposedly help you with questions that you can turn in from a textbook if it was assigned to you from a textbook, or you can turn in as a cut and paste from a PDF if a professor assigns you questions on a PDF. And you can turn in questions to Chegg, and they will help you with these questions by, so far as I can tell, sending you solutions and answers, which might help you or might, well, all right, I gotta be very careful about this. No, I don't think they are reliable. Let me be very careful. I'm saying there are reliable sources out there that are great, but there's one called Chegg, which honestly, in my opinion, and I'm saying this on record, like this is gonna be on a YouTube, I think that's a service that helps people cheat. I don't think it teaches people, I think it helps people cheat, because you literally can type it, you can take questions from our exam, cut and paste them, send them to Chegg, and they will send you solutions straight up as long as you pay. They'll send you solutions to our questions, even if we just wrote them the night before. And then you can cut and paste those and put that into your exam and submit it to me. Now, I'm not recommending that to anybody. It happens all the time. I'm not recommending it. What I do recommend Khan Academy, by the way, for learning to like understand things that are going to be on your exam. If you don't like the way definitely Khan Academy is great. I don't consider that cheating at all. I think they're wonderful. And I think something called 3 blue, 1 brown, or 3 brown, 1 blue is an even better version of that. That's more sophisticated and advanced. All those things are great. Chegg like allows people to cut and paste questions and then get cut and pasted answers. Now, so why am I bringing it up? Just to make absolutely clear to everybody, even on our exams, are you allowed, like, what if you disagree with my opinion? What if you already have an account? Are you allowed to use Chegg on our exams? Yeah, you are. I will not actively punish anybody for using even what I consider to be a shameful site. I think they should be ashamed of themselves. And I think people that use them ought to be maybe ashamed of themselves, but you can do whatever you want. You can use whatever resource you want to do one of our exams. The thing is, we're then going to grade the exam knowing that you could use whatever resource you want. So what we're grading on is how much understanding you convey, not how much correctness. Like, I know where to get the correct answer to these things, right? But what you guys are going to show on your exams is how much you understand why the correct answer is the correct answer. Time and time again, I'm just telling everybody, stuff that's coming from Chegg, we didn't even know it was Chegg. We weren't looking to punish anybody. We weren't looking to catch cheaters because we don't think the cheating like is an issue that anybody should be all obsessed about here in physics. But time and time again, we would find ourselves giving bad grades and writing like wrong on stuff that we were like, God, this is like wrong, but I feel so bad. Like this person's doing so badly. Why is this so, there's something they're just not connecting with the material. Like, there's a bunch of stuff here, but it's not right. And it would turn out time and time again that bad material that was getting bad grades for reasons that we couldn't figure out like why, because it seemed like it was good students or whatever. It was stuff that was coming from Chegg, to be totally honest. Like, in other words, I'm saying it's not against the rules to use bad sources, but what you guys want to do is use good sources in order to do well. And I don't advise Chegg. I don't mean to be like, I don't advise Chegg. I'll give you better ways to go about doing things because I think they're there to help people cheat. And I think it becomes clear because they actually don't actually help people understand what's going on. But yeah, you can type my name into Google Images and you'll see Chegg stuff all over the place. You'll see all of our past questions answered by them. And I don't think that those answers got very good grades. So to be very clear, there are a lot you can use. The way exams will work is open everything, but think of it as you have a day to walk into the worldwide web of physics geniuses, but you got a day to walk in and talk to any genius you want in the world about your exam, but you got to come out understanding what the person taught you, not just come out with a bunch of words. So it's a competition of understanding, not a competition of acquisition. That said, that's the way our exams work. And that said, all that said, I'm just getting this off my chest because these are good questions and I just want to put perspective on things. But all that said, our tests are designed so that everybody could get an A. They're meant to reduce stress and reduce fake surprises and artificial challenges and meant to just be about physics. That's what we want. We want by the time you get to our test that what you're thinking about with all your might with your friends is just physics, 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 and that you're all just trying to get an A from it and get an A together. That's what we're looking for. So that's how the tests are designed. And we'll show you other resources too that are good. But okay. So I don't know if I want to, again, I still would like to let you go early if I can, but I also want to shift gears and start boring everybody. So what I'm going to say is, hopefully you've received the very first assignment in your Google Classroom. It's due a week from today. We're going to start it right now in breakout rooms. Like I don't think I've done this yet today. Wait, have I? I can't remember, but I'm going to put you all in breakout rooms, like that's 3 or 4 person a room. And I want you to together in those rooms, start just like literally working on this homework together. You can take out old notes from any old physics class that you've taken. You can go on the web together, but I want to get answers. This homework now will start getting mathematical looking, like they're all right and wrong answers on it. So I want you to start. If we get far enough, I might ask everybody to submit what they've done so far today to just get 25 points before we're getting rolling. Oh, and there's a question. I'll answer the question in one. But one other thing before I forget that you're going to start today. Wait, what is it? Just hang on. I just almost forgot. Oh, be prepared though. I'm going to put you in these rooms. The main purpose of the rooms is that so you can work together and not worry about what I think. Like that's the purpose of them. But I'll walk around sometimes, but I'll also scramble you. Don't be surprised if all of a sudden you get moved into a different room. That's not a personal thing. That's just my way of keeping everything jumping and keeping everybody working and actually being productive at the time. So, but all right, before we do this, there's a question. Someone just had a question.
Yes. So yesterday we had to find the acceleration of the spring. How do we find that?
Oh wait, that's a really good question, because you're right. That's also on the homework thing. Oh, I'm sorry. So you were asked that with Walter's. He asked you about the acceleration, but we didn't go over it. You don't know how to. All right, that's a great. Oh, okay, great question. And here's my answer. If we assume that this is true, so we're assuming but if we also assume that this is true, well, the first thing I should ask, I believe, well, do you know the mass of the mass on the end of your spring from yesterday? I mean, do you have figures for masses?
Yeah.
Okay, so my fast answer is, well, and I think it's a very fair question, and I don't mean this answer as anything but an answer. It's true specifically for spring forces that F equals negative kx. I'm believing from physics 1 that it's true of all forces, that for any object, the sum of all forces acting on that object produces the acceleration of that object. In other words, what I'm saying is if you know the figure for force and you divide by mass, in this case, you will get the acceleration. But because what you're working with is a situation where the only force acting on I believe the only force acting on your mass was a spring force. Like, I believe the springs that you're considering or that you were considering yesterday were horizontal springs, or is that not true? Were they vertical springs or horizontal springs? Am I making any sense? I mean, my answer is divide by mass, but I should ask, to be clear, the springs that you're thinking about or whatever you did with Walters, were those springs? And I know
It was vertical springs.
Oh, they were vertical springs. Okay. That does. So when you're asking me, so this is a good place to pause for a second. That's helpful. That means that at any given moment, well, so what you were talking about then, is if either you have a mass sitting on top of a spring, which is oriented vertically on a lab table, or if you have something like this, if you have like a mass hanging down from a ceiling and suspended from the bottom of the mass, if you have a spring hanging down from a ceiling and at the bottom of that is some mass, does either of these situations, what you're like, if you're talking about either of those situations, which it sounds like you are, then the first thing I want to say about that, and this is a good question, and if this is if we don't even get to the homework today, then that's okay too, but then the free body diagram let me pause for a second and say, just because I didn't do physics 1 with you guys. I don't know where everybody might be in different places in their mind with regard to physics 1. And of course, this is, whatever you call it, this is physics 2. It's based on physics 1. So let's make sure we're on the same page. I think if you have a vertical spring of any kind, if you have a spring that's up and down, either hanging from a ceiling or sitting on a lab table, and of course, I know that whatever you have is all fake right now. Like, we're not in a lab room together. I totally do get that. And that makes all this a bit abstract. to say the least. But if you're picturing a vertical spring or a mass on a vertical spring, then the free body diagram of the mass on a vertical spring, of the mass on a vertical spring. The free body diagram is this. It consists of two arrows. One arrow that points up, which is the spring force, and the other arrow is pointing down. That's the gravitational force. Now, one of those is constant, right? One arrow is always the same size. It's mg, always pointing down, always the same length. The other arrow, the kx force, and if you want, you can call it ky. If you prefer to use y for vertical displacement, that's totally anybody's choice. But whatever variable you use to indicate position, the spring force is the spring constant times that position. And if the first part of this lecture today made any sense, then what we're saying is that arrow, that varies all the time in both size and direction. Like, that spring force, if we're understanding what we mean by kx, it means that sometimes x is big and sometimes x is small. So sometimes kx is big, sometimes it's small, like it sometimes equals mg and sometimes doesn't. And furthermore, kx is sometimes pointing up, like if the mass on the spring happens to be below the equilibrium position, then the spring force will point up. But at any given moment that the mass happens to be above the equilibrium position of the spring, then that arrow will point down, right? So the free body diagram of a vertical spring is varying all the time, And what we know, and we may leave, this is just, again, to put spring, whatever we're doing this year about springs, to put it in the perspective of last semester, what we know is like the spring force is this, and the gravitational force is this. Now, should I put a negative sign there or not? I don't know. In fact, I really shouldn't make a decision. In fact, let me make clear that negative sign that goes in the Hooke's law, that means that whatever x is, F is pointing opposite to it. Like that's what the negative sign means, right? If the mass is on the right of the equilibrium position, then the force is yanking to the left, and vice versa. But however that relates to gravity, but the gravitational force is always down, right? So I'm gonna, whether you call the spring force negative or positive depends on what you've assigned to gravity. It depends on what decision you've made for your entire coordinate system. I'm saying all this just to say, let's leave aside the issue of signs for a minute. Whatever the signs are, according to physics, the sum of all the forces acting on an object, the sum of all the forces acting on an object is what accelerates that object. According to our free body diagram, there's two forces acting on a vertical spring, right? There's two forces. There's the kx force, which might be pointing up or it might be pointing down, I don't know. And there's the gravitational force, might be pointing up, might be definitely pointing down, but that might be counted as negative, or that might be counted as positive, I don't know. All that together will be the acceleration of an object on a spring, which is a very long way of saying, but an important way of saying, to get us rolling on this home, like basically we're gonna ask the same type of questions in this homework assignment. All of that is to say, A, the acceleration. It was very good that someone asked me this. I already forgot who asked me. I'm sorry, who? I think it was Andreas asked, like, what about the acceleration? Let me say the acceleration can be a simple question because it's just, oh, F equals negative kx and F equals ma. Like that's the knowledge you need to get it. But to get the answer, just notice whatever answer you get will not be a constant. A does not equal A naught, meaning A is not constant. A is not constant. It's going to vary from position to position, just like the force kx varies from position to position. What A is will depend on where the mass is in its trajectory here, according to what I'm saying, which doesn't mean it's an impossible question to answer. It means it's a little bit hard, maybe, if I don't have more information about exactly what you did in lab yesterday, but it's a little bit hard because, oh, sorry. I don't mean to make fun, but okay, sorry, go on.
So let's say we have a 20 kilos mass with a 4 meters of displacement. What's gonna be the acceleration of?
Oh, okay, that's good. So wait, so I'm saying, so hold on. I'm gonna call anything that's pointing up positive. I'm gonna call anything down negative. So you said, you had, sorry, give me the numbers again.
Mass 20 kilos.
Okay. And did you tell me the K or the stiffness of the spring or no?
No, and displacement is gonna be 4.
The displacement is going to be 4D or 4?
4.
It's like 4 meters?
Yeah, 4 meters.
Oh, okay. And one last thing, this is good. And by the way, for everybody, again, I think this is good. This is also even more concrete to get us to the homework. So we're going to do this. And then again, even if we don't get to start the homework today, you'll still go when you go. But Andreas is asking me, what is the acceleration given these facts? I appreciate these facts. I think though, if you're sure that you're asking me the acceleration, then I think there's one other fact I think I know what's going on here. You're asking me the acceleration, and when you say x equals 4 meters, what's at 4 meters? Like 4 meters represents what? The displacement.
The displacement after applying the 20 kilos on the spring.
Ah, okay. So then I do know what you're at. So if I understand correctly, so you have this spring that's sitting there at some position x equals 0. Then you put a mass on it. Put the mass of 20 kilograms on it, and then if I'm understanding correctly, now that mass sinks down to a position of 4 meters below, and it sits there at 4 meters below the 0 position. Does that sound right?
Yes.
Yeah. Great. All right. And this is a perfect place. Then I'll tell you everybody what to do with that. Then yes, this is a great question. That is the lab. If we knew that x equals 0 was the end of that spring, and then we place a 20 kilogram object at that place, and it falls down and comes to rest, like if it comes to rest at this spot 4 meters below, then what's definitely true is if the mass is sitting still at that new position, then that means it's sitting there at that position unaccelerated, right? A equals 0, which means, well, wait, I shouldn't even say that. Hold on. I'm saying what we definitely know is this. At that place, the spring force is pulling up, the gravity is pulling down. Together, they are the net force that accelerates that object. If the object came to rest at that position 4 meters below the equilibrium, what that means is that kx equals mg. The two forces are balanced, like not always, right? But at that moment that he's talking about, that Andreas is talking about, apparently if the 20 kilogram mass comes to rest right there, that means its downward weight is being perfectly balanced by the upward force of the spring. So that means then I don't want to go on the next page, that the K for this spring, the one thing he didn't give me, right, which I almost wanted to ask for, but then realized what he was saying. The one piece of information that we need about this spring, we can now figure out K must be equal to 200 over 4, I'm running out, which means, of course, 50. K is, I'll try to write this on the next page again, 50 newtons per meter. The original, what's the acceleration? Well, at that moment, it's 0. But what good does that do us, knowing that the mass comes to rest with 0 acceleration at that point, 4 meters below the equilibrium, means that that's how we figure out that K with those numbers, that spring with those numbers has a stiffness I'll write this again on the next page, has a stiffness of 50 newtons per meter. Let me, before I get, I'm just gonna write that again just so it's totally clear. I'm saying this, I'm writing the exact same thing again just so you can read the whole thing. I'm saying this. So I'm saying this. So I'm saying this. So I'm saying 20 kilograms times approximately, like G in my mind, G is approximately 9.8 meters per second squared, which means it's approximately 10 meters per second. I'm making that rounding all over X, and you said 4 meters. So I'm saying 200 newtons. Oh, once again, I'm 200 newtons over 4 meters is 50. I believe that the actual question probably that you wanted to face here was what's the K of the spring? I mean, the question I was asked is what's the acceleration, but I'm saying the acceleration is 0 and therefore the K is, does this help? Am I answering your question, Andreas, or?
Yeah, so it was, so what I gave you was asking to find the force basically. And in order to find the force, we had to find the K so I can calculate the acceleration. So it was like a three-part question in one, basically.
Right, I think that's, and I think you got all the, but now we got all the 3 parts, I think,
Yeah.
right? Okay, cool. No, and I'm glad. And look, everybody, I'm so glad he just brought that up. Like, that's very related to what we're trying to do right now, but it's always better if it comes from you guys than me. I would always rather answer something from one of you, like, because it means it's more of a conversation. So I'm very glad he just brought that up. Let me say, I think as a compromise, just to make sure I'm going to put you in the breakout room for like literally 5 minutes, just so you can all start on the first couple of questions of this homework. We're going to go for like 5 minutes, then we're going to come back and we'll discuss for 5 more minutes, not to finish the whole sheet or anything, but just to make sure that we can see how we will do this sheet by ourselves over next week. Like, I just want to get rolling enough so that everybody knows what it is we're doing. So I'm going to put you in breakout rooms for 5 minutes, then we'll come back and discuss 5 minutes. Hopefully it will be done by, again, I don't usually let people go early, but I feel like I owe it to you for missing last week and all that. And also it's just too boring to go like this. So 5 minutes in the breakout room, then come back and discuss, and the more clear we all are on the homework, then the more we'll just go. So bear with me for a second. Here we go. Yeah. Okay. And so, yeah, please go to your breakout room as Susan says join. Great. Great. Thank you. Great. Thank you. Thank you. Great. So please go to join your breakout room, Susan. Vicky? Ariel? Anastasia?
Yeah, I'm here.
Oh, sorry. Okay, you didn't get a sign. Sorry. So we're going to breakout rooms now. For some reason, you didn't get a sign. I'm sorry. Please, you're going to get a thing in 1 second. I don't know why. Okay, so please go to your breakout. And then is Ariel, or wait, yeah, Anastasia, tell me if you should get a, yeah, okay. Thanks. Ariel here? No?
Yeah.
Oh, okay. Sorry. I don't know why you didn't get assignment. It's coming right now.
Okay, I see it.
Okay, great. Thank you so much. And Vicky, are you here? Vicky, no.
Yes.
Oh, sorry. Okay, you should get, I don't know why you didn't get assigned, I'm sorry, but you should get an assignment in a moment of
Oh,
work. Do you
okay, I-
see? Oh, you got, okay. Okay. Hello, hello. Okay, everybody's back. It looks like. Thank you for your patience. You can all hear me and see me, yes? Or hello? Oh, no? Oh, yes. Okay, thank you. Awesome. Thank you. I love that picture, man. That's great. Wow, wait, this is the highest oh my God, wait, is this like a joke? Wait, I just noticed how many dogs are in these pictures, which is fantastic. And it almost seems like you would have had to arrange it as a joke. Let's each make sure there's a dog in our picture just to mess with his head. Well, either way, it's awesome. Oh, it's a baby goat. That's hilarious. Okay. Okay, so I'm totally wrong. That just goes to show you I am bad with biology, apparently. Okay, I totally did not know there was a baby goat. Okay. All right, so wait, so we just went into the breakout rooms. Again, I feel this need to let us not go all the way to 5:30 today, so I don't know why, but does it, how about the first couple of questions? Does anybody want to share? Like, did anybody feel like they got an answer, or does anybody want to say anything, or a question, or an answer to the very first question, just so we can see where we're at?
So when using the formula F equals negative KX, the X, do we use 0.15 M?
Right. Yes. Good. Good question. And yes is the answer. Yes. Okay. So yeah. And thank you for reminding me what the numbers were. Yes. So and stop me if what I'm drawing right now, tell me if this is basically what you're looking at. And I know we provided a diagram in the picture. In general, whenever you're solving problems, it's always good to draw your own picture first, even if there already is one. You draw your own picture of the situation. And then while you're solving the problem, often you'll put in vector diagrams or free body diagrams or field line diagrams we'll get to in this class. Like, there's different types of diagrams that we can do as we're solving something. But even before we do those diagrams, we like to have a picture of what the problem is itself, right? So yes, I'm agreeing. I'm thinking that this is the problem we're given. Correct me if, if any of my numbers or anything are wrong, but what I believe is you've got this spring, you've got this mass at the end of the spring. The spring has a stiffness of 200, I believe it's stop me if I'm wrong, but I think it's 200 newtons per meter. Yeah. Oh, sorry. Oh, good. Oh, good. And if you have the answer, I'm going to totally want to hear that answer in 1 second. You probably do. That's awesome. Let me just make sure we're all talking about the same problem. That the spring stiffness is 200 newtons per meter, and that's a constant that will never change throughout this problem. That the original equilibrium position of the spring we always call 0. But then what we're saying is, and I totally do want to hear, I forgot already who was it. It was, right. I want to hear your answer in 1 second. I just want to absolutely make sure of one thing. Sorry, that this. Oh, feedback. Whoa. I don't know what just happened. That's interesting. Okay, well, anyway, just to make absolutely clear, notation, and again, this is probably, good question. Yeah, oh, cool. I like the way you guys are working together. I could like walk away and you guys got this. All right. Cool. I'm watching the chat. The chat is fascinating. And we're about to wrap up because clearly, yeah, it looks like you do got this. Let's just make sure we're on the same page with notation and everything else. Yes, if the very first question was asking for a force, which I believe it was, if the very first question was asking for a force, you are right to believe that it's looking for something in newtons. Yes, and you're right. If you just if you multiplied a couple numbers and got an answer, you're probably right what you think your answer is. I'm going to ask in a second, but let me just. Well, actually, no, fine. I'll kill the suspense. Yes, could you tell me who was it? Was it Alexandra? Could you say what you think the answer is?
I got 30 newtons.
Right. I totally agree. That's awesome. That's awesome. That's awesome. Yes, yes, yes. And if we just proceed through the whole rest of the homework answers like that, you'll get 100%. So yes, the answer to the first one is 30 newtons. Now, strictly speaking, one might argue that it's negative, right? If that 0.15 to the right is considered positive, then the initial force on this mass would be exerted to the left. And strictly speaking, we would probably want to say negative 30. But whatever, like in and of itself, right there, depending on how the question's asked, I wouldn't necessarily take up. Well, I don't want to get into, but yes, 30 newtons, I definitely agree. Yes, she was right to just multiply 0.15 times 200. That question is not supposed to be a trick question. I want to make this very clear, especially since we're going to go soon. All physics is like this. Like the first couple of classes may be boring and simple. I don't know, but whoa, excuse me for 1 second. Excuse me for 1 second. Sorry. Okay, this is a plug and chug. The first one is a plug and chug, and I don't mean to diminish it. But let me make it clear: it's not meant to be a trick question. Everything builds in physics, so often why we'll ask a question like that first is not to trick you, also not to just see if you're paying attention. But what we're really trying to say, we're ultimately in all physics problems trying to get to something hard. And the last question always builds off the prior questions, as you may have noticed in science. And so often the first few questions we ask, they're not just warm-ups or they're not just exercises, but what they're doing is trying to direct your attention to the procedure of how you answer something harder. In other words, this whole homework is a series of questions that are going to build ultimately towards something a bit hard. And that's what always happens on the exams. So you should always give yourself full credit for writing down the stuff, even if you think it's easy. I'm saying all this to say, yes. The answer to the beginning is 30 newtons. I think strictly speaking, maybe negative 30 newtons. But notice, like, the very good question was, how did we know to use that 0.15? Like, did I, was it okay to use that 0.15 and multiply it by the 200? The answer is yes, for this reason. And then we're gonna go. X sub 0, I hope you know from physics 1, X sub 0, what we call X naught, means the initial position, right? What does that technically mean? Like, X naught is not always 0 in physics. X sub 0 in physics does not usually equal 0. It equals, by definition, wherever the mass was at time equals 0. Right? Like, literally in physics, any variable subscript 0 means the value of that variable always means the value of that variable at time equals 0. Now, what is time equals 0? It's wherever you start paying attention in an experiment, right? If we say that this mass is initially at 0.15 meters from the equilibrium, what we really mean is when we started our stopwatch, the mass was at 0.15. And what does that really mean? It really means that 0.15 is where we assumed the mass to be at rest. Either because someone's actually holding it there at that time when the experiment begins, or because we've been watching the mass go back and forth for a while. Maybe we've been watching go back and forth for a while, and we deliberately start our stopwatches and our counters at the moment the mass gets to a turning around stopping point and starts going again. In other words, the actual definition of X sub 0 for a mass spring system, the actual definition of what we mean by initial position, is the place where the mass has 0 velocity. That's what I'm really trying to say right here, just to be clear. And that is not the same thing as position 0. X sub 0 is where the mass has 0 velocity. That is not the same thing as equilibrium. You may want to think about that over the next week, but equilibrium is not the place where an object has no velocity. Equilibrium, this is the last thing we're gonna write and we're actually gonna go to, but I totally agree with the answer. Yeah, the first question is 30 or negative 30. And then if you divide by the mass, you'll get the answer to the next question. They're not meant to be trick questions, but they are meant to build on themselves, and eventually they get a little bit hard. You will have to remember conservation of energy to do like a question 4 or whatever. But let me just summarize by saying this. For springs, This is like a little bit of a weird mouthful that you may want to think about. I'm saying the place that we call the initial position of a mass on a spring is the place where it has zero velocity. That is not the zero position. The zero position of a mass on a spring, the equilibrium position is the place where there's no acceleration, not no velocity. That's a little bit confusing. That's what you're going to see. That confusion is kind of what we're probing in the homework assignment for next week. That like, if a mass on a spring goes back and forth forever, for example, the center of its oscillations we call equilibrium. And that place is not a place of zero velocity. One of the next questions in the homework is going to ask you to get the velocity of the object at equilibrium. It won't be zero. It'll be a number. In fact, I'll tell you right now, if anybody's paying attention, the answer will be 3.87 meters per second. I'm telling you that right now. You can use it as a check if you're doing it right or whatever. The answer to the velocity, when it asks in the homework, what's the velocity at equilibrium? It's not zero. If you do it correctly, you'll get like 3.87 meters per second. That's the velocity at equilibrium. The velocity at equilibrium is not zero, but the acceleration at equilibrium is zero. That's the difference between equilibrium and a turning point, or what we call an amplitude point. I'm going to just, yeah. Oh, we give you, this is a great question. Samantha's question. Oh, not only, yes, we will give, first of all, for every exam, we'll totally give you a sheet of all the equations that we use, but better than that, or more to the point, and I would have done this today had we started last week. Next week, or next class, either with Walters or me or both, you're going to get a list of all the equations in advance. There's 10 specific equations that we try to establish in this class. We call them motions. It actually forms the curriculum of this class. We're going to talk more. You're going to get an equation list before, during, and after we develop those equations. And yeah, they're super important in the class, but you'll never be asked to memorize that list at all. But you will accidentally, if you do everything right in this class, you will have memorized it by accident by the end. But yes, we will give, so far, the only equations we have so far are F equals negative kx, because you supposedly established that in lab yesterday. And we also have F equals ma, because we believe that's always true in physics, like from the last physics class. But that's all we have so far. That's a great question. And we call them equations, not formulas, but I'll tell you why next week. I promised I would let you go a little bit early. I think it's still time to do just a little bit of that, if there's no other crises or questions. You now have the homework due next Wednesday. You'll see Walters before then. I'm good to go if you're good to go, everybody. Are we good? Shall we say goodbye for a moment?
Yes.
Oh, and I will put, thank you for reminding me. Yes, this thing has to finish record. It has to, decode and all that. But yes, not right at this moment. It'll take me a couple hours, but I will post the video of this whole class on YouTube on a separate playlist for your class. Yes, don't. Oh, also, thank you for reminding me. I will post the video of this class tonight. I will also send around a PDF of all of these class notes. Like, there's not that much today. There's not that big of a deal, I know. But as our notes get more prodigious, it will be useful. So you'll get from me tonight a PDF of these notes that I wrote down on the board, and you'll get the lecture video. I still, of course, encourage everybody to pay attention and take notes for 1,000 reasons. But yes, yes, I'm totally posting the video. Yeah, don't wait up for. It'll be tonight. It won't be right this moment, but it'll definitely be before tomorrow. And yes, I'll also send around a PDF of these notes that we took, or that I took. And you guys are awesome, and thank you very much. Now it's almost not early, which is too terrible. So thank you very much for your patience and flexibility. We will meet again next week. I'll get your homework before next week. You'll send it to me. Even if you don't think it's all right, please try to do every question. The last question's a doozy. You could do whatever research you want. You can work that out, blah, 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 but try to address every question to the best of your ability. Okay. Thank you. Thank you very much. Okay. Awesome. You guys are great. Made a few. Thank you. Thank you. Very nice to meet you all. Okay.